Alright, so again, we're talking about error propagation, and the basic premise behind error propagation is, say you're trying to, like in real life, when you're measuring things, right, you always don't know exactly how long it is. Like say this is like 0.3 meters plus or minus 0.01 meters, and this is 0.4 meters plus or minus 0.02 meters, right? And then you want to see what's the length of this segment together, okay? You want to perform some operation. Yeah. Wait, do you say something?
Yeah.
You say, yeah, okay.
See, I'm a good audience member.
Yeah, good audience member. If you want to add these two together, for example, is it going to be 0.3 plus 0.4 simply 0.7? And then, what are you going to do with this plus or minus 0.02, 0.01, right? And what we're going to do, this is where error propagation comes in handy. This thing right here. So there's the equation. There's a couple of equations you have to memorize. So this is going to be kind of weird symbols at first, but I'll explain to you what it means. This is the uncertainty, and this is the total. So this is this plus this. The total after the calculation, and that's the uncertainty in the total. And that's equal to the square root of the uncertainty in the first one, the first measurement, plus the uncertainty in the second measurement, plus, and you just do this for all of your measurements. Actually, I'm just going to call this A1, A2. Okay. So you're just gonna apply this formula to all of your measurements. And I'll give you an example of how this works. So like in this example, what we would do is if we wanted to find the uncertainty after we add these two together, right, then we would just say that the uncertainty, let's call this segment A and let's call this segment B. The uncertainty in adding A plus B is equal to the square root of whatever the uncertainty is in here, 0.01 squared, plus whatever the uncertainty is here, 0.02 squared, which is equal to something. But that's going to be the uncertainty after we add this together. So it will be 0.7. Actually, I'll write this. 0.7 plus or minus whatever this uncertainty is. Okay, so it's pretty simple. You just gotta memorize this formula. Okay, so this formula only applies when you're adding or subtracting, okay? If we instead wanted to find like the area of something, say like we want to find the area of this square, pretend this is a square, then we would have to do A times B. And that's a different error propagation, it's a different error formula than this formula right here. Okay, I'll get to that soon. Actually, I'll get to that right now. Okay, so do you write this down already? Let's see if this video can caught it. Okay, cool. So I'm gonna erase this formula now. So say instead we wanted to find the area of this rectangle that we measured to have these dimensions.
I heard you say dog Dave. Okay, sorry.
Bonjour!
You're a dog. Okay, the equation for multiplying or dividing, so say, okay, so hold on. Some q value, some number after you multiply or divide is equal to, like, just say A times B times C over X times Y times Z. You know, it can go on for as much as it wants to go on for. Okay. And then okay, what does this mean? Right here?
Uncertainty.
The error, the uncertainty, NQ, after you do this calculation, is going to be this
What is
formula.
that symbol again?
Stylized D.
This? No. I don't know what the symbol is.
No, it's
It-
called, I'm pretty sure it's called
Stylized
stylized
D.
D. It's so random.
Isn't it like actual Greek?
No,
I thought it was a Greek letter. Well, anyways. So the equation is going to be the uncertainty in A.
Stylized D is like this.
No, you're thinking of like Cal 3.
Yeah,
That's
yeah,
not
yeah.
the same thing.
Yeah, no. That's wait, I'm trying to-
You're just adding up all these again. It's very similar to before. But the only difference is that you're also dividing it by the value. That's the difference. So like it's, you just add up all of these terms. It doesn't matter if it's multiplying or dividing. You're going to be using this formula to calculate the
Wait,
error
for
in
the-
Q.
For the previous one,
Uh-huh.
like where you were just adding them up, your final thing was like 0.7 plus like the uncertainty.
Yeah, 0.7 plus whatever uncertainty.
Shouldn't it be like plus or minus, or is it just plus?
It's plus or minus.
Oh.
I think I wrote plus or minus. Nice.
What just happened? How did I do that?
Same, dude.
So okay, so again, for this example, pretend that this is supposed to be a rectangle, not a rhombus. So then we have Q is equal to 0.4 times 0.3, right? So like A, B, C, X, Y, Z, these variables, they represent that absolute value that you calculate before the uncertainty, right? So this is what Q is equal to. Oh wait, hold on, I made a little mistake. The mistake is that I forgot to divide this by Q. So here's actually the equation. Can you see that well?
Mm-hmm.
So the uncertainty in the product or division divided by the actual value of the division is equal to this.
Okay.
So again, for this example, I'll just rewrite this a little bit.
Wait, why isn't there like a wait? So for multiplication and
Yeah, what's your question?
Division or multiplication.
Yeah, that's what this equation is applicable for.
wait, what is Q? Wait,
Q is the product after you.
and what's the X, Y, Z on the
Figure this out.
bottom? Like, what are
It's just
those?
like whatever values that you're trying to divide, like whatever values. It doesn't matter. I just wrote it just because.
Oh, so it'd be like the equivalent of like the adding. It would be like A
Yeah.
plus B, and then there could be some
Right.
subtractions. or whatever in there.
Yeah.
Oh,
It doesn't
okay.
matter. It doesn't matter. Multiplication or division is the same formula. That's what the point is. So like, say
So like for this trap or for the parallelogram thing, since it's only multiplication, there's no like X, Y, Z term.
Well,
It's just
yeah.
an A and B.
yeah, but the point is like even if there was divisions, it would still follow the same formula.
Okay.
Right. Makes sense. So I'm gonna do this example here. So Q, the product that we're trying to find is the area of this rectangle, and that's 0.3. So that the actual values that we calculated, that's not the uncertainty, times 0.4. Okay. And then the uncertainty in Q divided by Q, right? That's the formula. Divided by the absolute value of Q is equal to the square root. What's this term right here going to be?
You're gonna have
Point
the
zero
error
one over
propagation of A
whole squared.
over
Yeah, so
the value of A.
yeah, so 0.1 over
Oh, it's 0.3.
0.3 squared. And then I'm gonna add again the error in B, which is 0.02, divided by the value of B, which is 0.4 squared.
Never
Like if
mind.
we start like exponentiating them, like would we just treat it as like repeated multiplication?
I'm actually about to get to that next. There's a
Okay.
different formula for exponentiating. And like the intuition behind why it's different is because if you're exponentiating a value, that has it's like the same error that you have, right? It's not like you have two different errors. So it's gonna propagate differently through calculations. If that kind of makes sense.
Yeah. Wait, Joaquin, for this first one, for the
Yeah.
addition, what was the final answer? 0.7 plus or minus? Oh, you didn't calculate it? Can you
What,
calculate
this?
it? Whatever, I'll do it.
Wait, the addition of what?
No, this one. This first one we did?
Oh, I don't know.
So let's say that we can approximate this rectangle to be a square, and then we're trying to find the area of the square. Okay. You guys ready?
Mm-hmm.
Yeah, yes.
Alright, so that means that we're going to have to do this value squared, right? So in order to get the error propagation of something squared, say the value after you square it is equal to q is equal to x to the power of n, okay? And n has to be an exact number, so it can't be like okay, so the propagation or the error in q divided by the q, the absolute value of q, is equal to absolute value of n times the error in x divided by the absolute value of x. Okay?
And
So, huh?
What happens if it ends negative?
I
I mean, I assume since you're taking the absolute value of n, this will still work, right?
yeah, I think it'll still work, yeah.
Okay. Yeah, just need to-
So if we were to do this practice problem, so we're trying to find a squared. So a squared is equal to 0.3, right? 0.3. Actually, this is not a. This would be q is equal to 0.3 squared, right? So x is equal to 0.3, and n is equal to 2, right? So then the error in q over the value of q, well actually I'll just say the value of q is, what's 0.3 squared? 0.09, right?
Mm-hmm.
It's equal to 2 times the error in x. Error in x is 0.01 divided by absolute value of x, which is 0.3. Okay.